All right, let's go ahead and get started. I do want to welcome you to this worksheet. This is gas laws part 2. You will need a calculator for this one, so if you don't have one handy, go ahead and pause the video and we will get started. Folks, in this worksheet, we're going to be looking at Charles's law, Avogadro's law, Gay-Lussac's law, and Boyle's law. So let's go ahead and start with number 1. It says a 14.8 liter balloon is at 255 Kelvin. What will be its volume if the temperature is 304 Kelvin? So we're looking at the relationship here between temperature and volume. That's Charles's law. V1 over T1 is equal to V2 over T2. So now it becomes simply a matter of finding the variables that we're looking for. The 14.8 liters is the V1. T1 is the 255 Kelvin. V2 is what we're looking for. It's the volume, V2. And T2 is 304 Kelvin. So Charles's law says that there's a direct relationship between volume and temperature. As the temperature increases, the volume increases as long as the pressure remains constant. So V1 over T1 is equal to V2 over T2. V2 then is equal to V1 T2 over T1. That's how you algebraically get to what you're looking for, V2. So now we say V2 then is equal to, now I'll plug in 14.8 liters times 304 Kelvin divided by 255 Kelvin. And when we do that to the correct number of significant digits, we get 17.6 liters, and that'll do it for number 1. So 17.6 liters is number 1. Let's look at number 2. It says if 0.242 moles of helium occupies 9.9 liters, how many moles must be added to inflate the balloon to 17.0 liters? So N1 then is 0.42. V1 is 9.9 liters. N1 is what we're looking for, and V2 is 17.0 liters. We're going to use Avogadro's law, which says that there's a relationship between volume and number of moles. V1 over N1 is equal to V2 over N2. So now let's solve for N2. N2 is equal to V2 times N1 divided by V1. So the amount we need to add is N2 minus N1. That'll be our answer. So now let's determine N2. N2 is equal to 0.42 moles times 17.0 liters divided by 9.9 liters. So N2 then is 0.72 moles. Now remember, we're asked how much we need to add, so we're going to take that 0.72 moles and subtract how much we originally had, which was 0.42. So 0.30 more moles are needed. That'll do it for number 2. Let's go to number 3 now. Number 3 says, at what temperature will a balloon have a volume of 6.08 liters if the temperature is 41 degrees Celsius when the volume is 4.87 liters? So T2 is what we're looking for. V2 is the 6.08 liters. V1 is 4.87 liters, and T1 is 41 degrees. First thing we're going to want to do is convert that 41 degrees Celsius to Kelvin. Remember, all temperatures are going to have to be in Kelvin. To do that, we're going to simply add 41 plus 273, that's 314 Kelvin. We're looking here at the relationship between volume and temperature, so that would be Charles's law. V1 over T1 is equal to V2 over T2. So now let's solve for T2 by pulling T2 up and V1 down. So V2 times T1 divided by V1 is equal to, let's plug in, 6.08 liters, that's the V2. T1 is 314 K, and V1 is 4.87 liters. When we do that, multiplication on top and then divide by 4.87, we get 392 Kelvin, or if you want it in Celsius, just subtract 273, we get 119 degrees Celsius. Let's look at number 4. It says the pressure inside a sealed container is 97.9 kilopascals when the temperature is 298 Kelvin. What will be the pressure if the temperature is 376? So let's identify our variables. P1 is the 97.9. T1 is the 298 Kelvin. And then P2 is what we're looking for. That's the pressure we're looking for. T2 is 376 Kelvin. In this case, we're going to use a law called Gay-Lussac's law. Gay-Lussac says that there's a relationship between pressure and temperature, and this is that relationship. It's a direct relationship. P1 over T1 is equal to P2 over T2. As temperature increases, pressure increases, assuming that volume remains constant. Now we're solving for P2, so we say P2 is equal to P1 times T2 over T1. Now let's plug in. That's equal to 97.9 times 376 divided by 298. When we do that, multiplication on top, divided by the 298, we get 124 kilopascals. That's our P2. 124 kilopascals, and that'll do it for number 4. Let's look at number 5. Number 5 says the air in a syringe has a volume of 25 milliliters when the pressure is 4.38 atmospheres. What will be the volume when the pressure is 0.65 atmospheres? So let's identify our variables. We're looking for V2. P2 is 0.65 atmospheres, P1 was 4.38 atmospheres, and V1 is 25 milliliters. This is the relationship between pressure and volume. It's a direct relationship. It's an indirect relationship, an inverse relationship. As pressure increases, volume decreases. So Boyle's law says P1 V1 is equal to P2 V2. We're solving for V2. So V2 is equal to P1 V1 over P2. Let's plug in. P1 is 4.38. V1 is 25.0. P2 is 0.65. That's equal to 170 milliliters. 170 milliliters then is our final answer. That's the 2 significant digits. That's number 5. Number 6, what is the pressure inside a tank when it contains 87.3 moles of helium if it holds 52 moles at 9.63 atmospheres? Again, let's identify our variables. N2 is the 87.3 moles. P2 is what we're looking for. P1 was the 9.63 atmospheres, and N1 is 52. We're going to be using P1 over N1 is equal to P2 over N2. Let's solve for P2. P2 is equal to P1 N2 divided by N1, and now let's plug in. 9.63 times 87.3 divided by 52.0. So P2 then is going to be equal to 16.2 atmospheres. That does it for number 6, and that does it for this worksheet. I'll see you on the next one. Thanks. Bye-bye.